So this presentation is about KNX City, which is actually our initiative in order to integrate KNX or KNX installations with smart grids. Okay, first, well, the 6 parts of this webinar or this presentation. So first of all, why do we need it? What is the what is our response to that question actually? How exactly can KNX help indeed? What about renewable energy management? Then part 5 will be about KNX devices and development of those KNX devices in general, and a few technical details in part 6. So first of all, part 1. So why do we need this? Well, I start with a fact, something that we of course already know, but okay, here it is. Cities today already consume and pollute, and indeed it will only get worse. So example given, today 50% of the worldwide population already lives in cities. The expectation is that by 2050 this will go up to 70%. As a result, that means that even more houses and more buildings will be needed. So only on top of that, it means, of course, means that there will be a continuously increasing demand for energy. And moreover, not to forget, of course, also demand for mobility will increase. To put this in figures, the expectation is that by the year 2030 the number of cars will simply double. So what is the conclusion? That indeed the energy demand that it, well, at this rate will eventually exceed energy supply. So the question is there indeed something we can already do today in order to prevent this situation? And the answer is yes. It's a concept called demand response. So more details about this demand response concept in part 2. So the answer is indeed, as I said, demand response. So what is the base for this? Well, it's actually a mandate. The mandate is called M490, which has been issued by the European Commission in the year 2011. And the purpose of that mandate is to have one day smart grid standardization and smart grid development. Step 2 is that the Smart Grid Coordination Group has been founded. Step 3, that the Smart Grid Architecture Model has been developed. And in step 4, the mandate M490 has been associated with other mandates. M441 for smart metering and M468 for well, the mandate for charging of electric vehicles. So the result of that is, as I said indeed already before, the demand response concept, which means that we will have the possibility to adjust building loads in relation to smart grid events. What are smart grids, in case you're not familiar with that term yet? Well, the definition of a smart grid is as follows. So a smart grid is a conventional electrical power supply network, but combined with information and communication technology that we all know as ICT. Yeah? We can distinguish several drivers. So there's one driver at the generation side. This generation side driver, however, is not relevant here. I'm sorry, it is relevant, but it's not in our focus. So it's beyond the scope of this presentation. Yeah? Of course it's relevant. On the consumption side then, there are also, well, there are 2 drivers there. One is called KNX tariff, and the other is called smart metering. But more details on those drivers in the next coming slides. So what is the conclusion? Well, a smart grid is indeed an infrastructure in order to adapt building loads in a smart way. Demand response on KNX. So the challenge is demand response. Remember, indeed, as a result from the mandate 490, Also remember, it's a concept that allows adjusting building loads in relation to smart grid events. What is the solution? The solution is called demand side management, so abbreviated as DSM. So what we will do here is to change building load behavior based on energy tariff. So that's the concrete the concrete solution for this. This DSM, or demand side management by KNX, is called KNX City. Next coming slides, I will present a KNX City example in order to point out, in order to prove to you, the use of it, or let's say the benefit of it. Because I will compare two situations: a situation before KNX City technology, let's say. So in that before situation, we have energy consumption which is not related to tariff, and that can lead to dangerous situations. And we have a situation after KNX City. So after KNX City technology has been implemented, then we will have a situation where energy consumption is related to tariff, and this will indeed avoid danger. So here it is. Next slide, more details. So this is the situation before. Now just imagine the situation in a city in summertime, where and on a very hot day, let's say, it's very warm outside. So look at the picture, as you probably also, well, I hope also can see that you can also see on your screen that it is an apartment building with several floors, and each such floor has several windows, and each such window, as you can hopefully also see, has an air conditioner unit on the outside. So what is the situation before KNX City? Well, that there is actually, so we have let's say an air conditioner per apartment, but we don't have a smart grid. Not having a smart grid means that there is no energy consumption feedback. So there's no real-time tariff that can be used as incentive. And this is, this actually means that there is indeed no relation between air conditioner set points and grid load. So we have no idea what we are doing here. And that could indeed lead to dangerous situations like grid overload, or even in worst case blackout, of course. So this is the situation. We just take energy, and that's it. In the situation after or let's say with KNX City technology, this looks totally different. This time we do have a smart grid, so that means that the energy provider is at all times aware of our consumption individually, but of course more important, the sum of that energy consumption. And this is done via smart metering. So each apartment will have a smart metering device, and that will indeed inform the energy supplier of our energy consumption. Based on that information, the smart grid or the energy provider can indeed calculate a tariff or define a tariff, which then again will be used as input for the KNX installation. So it will be used as input. This is KNX tariff information, or this energy tariff, maybe better said, will be used as input for the KNX installation in order to take decisions accordingly. So what I mean is that indeed the real-time tariff energy information will be used as an incentive. So in case, so it could be indeed the decision of the KNX installation, so to say, to increase the air conditioner set points, instead of instead of decreasing the temperature, it could be the decision to increase it, because the KNX installation found out actually that the energy tariff has been increased. So therefore, that decision. Yeah, just as an example, of course. Well, the result is that that there is indeed a considerable grid load reduction without compromising comfort, because example given, or an example that I gave indeed, is increasing the temperature with just 1 degree Celsius is not something that we necessarily experience as being unpleasant or uncomfortable. Yeah? Certainly when we think of the consequences or the advantages in this case. Yeah? Just 1 degree Celsius and we avoid blackout. So that is of course a price we can pay. Okay. How exactly can KNX help here? Well, first of all, as such, already today with KNX we can save a lot of energy. Yeah? So it is proven with facts. So this is information that I have from publications which are based on independent scientific research. So has nothing to do with KNX or KNX Association as such. This is independent research. Yeah? So what has this research? What has been proven there? That first of all, 40% of the total energy consumed within a building, that 40% of that total energy can be saved with or by using KNX shading control, 50% by using KNX individual room control, 60% with KNX lighting control, 60% with KNX ventilation control. And these are of course individual controls, so if we combine the different types of control, then the percentage will only go up. But there is still a huge potential of energy that can be saved. And this is exactly the purpose of KNX City, in order to address this potential. So the purpose is for KNX buildings to avoid wasting energy. Avoid wasting energy can mean reduce energy consumption, but it can also mean increase energy consumption. So it depends. Oh, there's a small mistake on the slide. Sorry, I will improve it by next time. Avoid production of greenhouse gases. This either directly or indirectly. And also the purpose is to avoid compromising comfort at all times. Yeah? So for whoever is using the building, the inhabitants, there's maybe members of staff, visitors, etc. Yeah? So these are the three aspects. KNX City concept. So the concept is as follows. So it's a concept that places actually KNX installations, so plural, in a bigger context. So therefore we call that a city. Yeah. So if we put together buildings, then we get a city. So what we do indeed is we link these KNX buildings to smart grids. The interfaces, as mentioned before, are tariff and energy consumption data, so as used as feedback. The concept then allows us to adapt KNX building loads based on tariff. So that means either switching on or off loads, or to charge batteries of electrical vehicles. Yeah. And other possibilities that will follow in the future. So, in summary, well, let's have a look at the KNX City keystones. Indeed, they are abbreviated as BIEM, where B stands for building. So B represents the KNX devices, the KNX interfaces for tariff and smart metering. I stands for infrastructure, so that's the smart grid, and it covers also the conventional energy generation. E stands for energy generation, so this is the renewable energy. This can either be on a local level or on a public level. So local we mean private and at your home or in companies. or energy or renewable energy generated publicly, so state-run. M stands for mobility, so that's the electrical vehicle as such, and also covered here are the loading or docking infrastructure in order to indeed load these electrical vehicles. So that can also be either local or public. One important remark here is about I, E and M, of course, and that is that these items or these keystones are of course relevant for KNX City. However, they are not in the focus of KNX Association as such. KNX Association will always and only focus on buildings, so the KNX devices and the KNX interfaces. Okay, renewable energy management. So as a consequence of KNX City, or as an advantage, next coming topic. So so what we will do with KNX City is indeed to change. So it's a concept called demand side management, which allows indeed changing building loads behavior based on tariff. There are two possible scenarios that we can distinguish. Either the tariff is favorable, or the tariff is, well, the opposite, unfavorable. So what does this mean in practice? So let's have a look first at the favorable tariff scenario. So just imagine this situation. So the initial situation where there is moderate renewable energy generation. So there is some renewable energy that is generated at this moment. It's not the maximum, but there's something. So let's suppose that this is indeed the initial situation, and this initial situation means that the energy tariff at that very moment is 15 euro cents per kilowatt hour. Now suppose that there is all of a sudden a change in the weather. Yeah, so there's a strong wind coming up. So strong wind, of course, obviously means that we have more renewable energy available, or more renewable energy can be generated indeed. So indeed, it could mean that this, a possibility would be that the energy provider indeed lowers the tariff, decreases the tariff. So from instead of 15 cents, the price will now be, because of that strong wind, will be 10 cents. Yeah. Because of that fact, the KNX installation, so to say, could decide that the example given, that the electrical vehicles could be charged at a higher rate, yeah, because the tariff is interesting now, or more interesting. It could also mean that we switch on low priority appliances, so typically a washing machine. So that could be the reaction. But of course, we always need to be careful. We always need to make sure that there is a balance, and therefore we of course need the energy consumption feedback. Yeah? Because it could be that if, well, let's say that it could be that we are in a situation where all of a sudden everybody is turning on the washing machine or charging the electrical vehicles at maximum rate. Yeah, that could be that yeah, maybe there's not enough information, sorry, not enough energy for that. So therefore, indeed, at all times, the power supplier will use this feedback in order to calculate the appropriate tariff. Yeah? And that will then be used as a feedback, again, in order to make sure that everything is in balance again. Unfavorable, well, that's the other way around. So we start with the same initial situation. So we have moderate renewable energy generation in the city at a tariff, which means that we have a tariff of 15 euro cent per kilowatt hour. We have a weather change, however, it's not in our favor. There's all of a sudden no wind at all. Yeah? Well, that means, of course, that we that there is not such that well less renewable energy will be generated, and a possible situation could be that the tariff therefore is increased to 20 cents, 20 euro cent. A reaction of the KNX building could be that electrical vehicles, because of the increased tariff, that the electrical vehicles are now loaded or charged at a lower rate. And also that at the same time maybe heat production has been reduced. And again, that's something I want to really make clear. Reducing heat production does not necessarily mean to reduce heat consumption. That's not necessarily the case, because we should always take into account the comfort of the user. Otherwise the user doesn't like KNX, and that's what we don't want, of course not. Okay, so also here, of course here also in this situation, we need to make sure that everything is in balance, because if all KNX installations will have the same reaction, maybe there's a surplus on energy even. So therefore, indeed, energy consumption feedback or energy consumption as feedback, in order to balance, in order to make the balance in order again. So, summary is that KNX indeed can be used, or KNX City more specific, can be used in order to optimize the use of energy. So again, if there's a surplus of renewable energy, then we can switch on low priority loads, and in that way we can buffer renewable energy. If there's lack of renewable energy, well then we switch off low priority loads, and we avoid grid overload by doing that. So the conclusion is that indeed KNX can be used, or is the solution to optimize the use of energy indeed. Part 5 is about the functional layout. So this is something interesting for possible developers. So here we have the global picture. So the core or the center of this is the smart grid. And the smart grid will get as feedback the energy feedback from the entire city, so to say, and that is done via smart metering. Some smart metering device will be installed in every KNX building individually, and that let's say that entire package of information will be used as feedback in order to define the tariff, the energy tariff. And for KNX means that this tariff will be converted into KNX tariff, and that KNX tariff will then be used by a device called KNX Energy Manager, which also takes input from possible generated or renewable energy that has been generated by the own building, the house or the office. So that will also used as input, will also be taken into account. What is also used as input by the KNX Energy Manager is the KNX smart metering. So that means this is actually the local smart metering. Therefore I call it the KNX smart metering, because it is a KNX device. Outside it is not KNX, this is another standard, not KNX, but it's the same principle, so therefore I call them both smart metering, but again we need to make the distinction outside the building, inside the building. So inside the building, obviously KNX smart metering. And all by all, the KNX Energy Manager will then influence, or let's say communicate with the KNX Load Manager, and it's of course the KNX Load Manager, or managers, can be plural, that then will have an influence on the actual loads of the building. And within the rectangle is indeed everything inside the building all the rest is outside, so the smart grid and the smart metering. So here we see that again separately, as I just explained before. That was a bit too quick, sorry. So, and here we see everything inside the building, as just explained before. The KNX affairs then, well, what I mean is, with this slide is I just want to point out what exactly is covered by the KNX specifications. Yeah? So that is the interface for tariff, so the KNX tariff here, so specifically the interface, and also the interface for renewable energy. And then of course the entire KNX Energy Manager is also covered by the KNX specifications, and the KNX Smart Metering as such also. And not to forget, of course, also the KNX Load Manager is covered by the KNX installation, and of course specifically the communication between the KNX Energy Manager and such a KNX Load Manager. Of course also covered by the KNX specifications. Okay, last part, the technical details. So first of all, I want to start with the tariff-based, different types of tariff-based management. So we can distinguish two. Type 1 is called time of use, TOU, and type 2 is real-time pricing, RTP. So in type 1 we will use static tariffs, and well, type 1 typically has no correlation with renewable energy generation, so it doesn't take it into account, so to say. This is something we can use as base for a KNX Energy Manager device. Real-time pricing then sorry, is based on dynamic tariffs, which can correlate with renewable energy generation. Not necessary, but it can. It is possible. Yeah? This is also based. This is also the base in order to realize a KNX Energy Manager device. Here we see an example of TOU, time of use. So indeed, it depends on the time of day what the price of the energy will be. Yeah, quite straightforward. Here we see the other type, or an example of the other type, so the real-time pricing. So we have three inputs, so the total load of the building, the tariff, and the renewable generation, renewable energy generation is used as input. Will be processed by fuzzy logic, and the result will be, or the output will be, different set points, set point A, B, C, and D. Yeah? So that could be an example for RTP. Load management. So also here we see two types. One is called by control, the other is called by optimization. By control, well, is actually the most, let's say, simple variant. So here we will adapt loads based on set points. Yeah? And is indeed the base can be used as a base for the implementation in a KNX, or the implementation of a KNX development, better said, the development of a KNX Load Manager device. By optimization, well, here it's a bit complexer, because here the optimization is about optimizing loads based on set points in combination with load profiles. And within optimization we have two subtypes. One is called prediction and the other is called real-time optimization. So also this type of load management can be used as a base for the development of a KNX Load Manager device. And to start, sorry, better said, to end the presentation, I just want to explain to you, or just give you the the explanation indeed of the so-called backpack algorithm, which can be used as a base for optimization so the as can be used as sorry, I have to rephrase that. So the back algorithm as base for real-time optimization. Yeah? Again, as a base for a KNX load manager device. So here it is, and actually, what this slide is actually telling us is that we can indeed use the same principle as the backpack principle. So that means if we are going on a trip and we only have one backpack for our luggage, well, then we have indeed in advance we have to decide what we are going to do, what we are going to put inside that backpack. And what we are going to put inside depends on two things. It's the weight or the volume of the object that we want to put in there, but also its importance, its priority, so to say. Maybe it's a small thing, but it's not important, or maybe it's a big thing, and it is really important, etc., etc. So we have several combinations, and this is exactly what this algorithm will cover. Yeah, and it's exactly that same algorithm that can be used for for energy in a building. So it's also here the same principle. Some loads are maybe not that big, but it depends on how important they are, and the other way around. Yeah. So again, it's a good principle in order to take care of loads in a building. Well, for now, I just have a few more ending slides for some general information where you can find more information, etc. And before I do that, I want to thank you for your presence here, for your attention. So maybe we see one another in a future webinar of mine. And for, I guess that's it then. So thanks again. See you, and